So let's talk about learning curves. That's section 2.6, learning curves. Should we do an example code? So I'm going to go ahead and we're going to use the same data set as before. I'm going to open it up. Save it as example 3. I'll leave my other code there for now. You know what? I'm not going to. I'm going to come up here to where I just build it. And I'm going to go generate learning curves. For linear model. All right, so I just want to use sklearn. So we're just going to go build the linear model. Model is equal to sk.linear model dot linear regression. Now, split the data into training and validation data sets, right? So let's go x underscore train, x underscore val, y underscore train, oh, sorry, lowercase, capital X, lowercase y, x underscore val, y underscore train, y underscore val is equal to sk.model underscore selection dot train underscore test underscore split. Open the parenthesis, hit. I do it like that. Okay, we'll go backslash. There we go. X comma y comma test underscore size is equal to 0 is equal to 0.2. That should make it 20% of it. I'm also going to assume that my test data has already been taken out, right? So that's why I'm calling it train and validate. And I'm just going to assume that somewhere on the side I have more test data that's just, I'm not considering it's locked away. Sometimes in big companies with a lot of structure, you know, like you might not have access to the test data. You only have access to the validation data.
Is y train and y val supposed to have a capital Y?
No, I have them as lowercase. Because they're not matrices and it's only one feature, but if you want to do capital, it won't. It's a decision that was made and may or may not be the correct decision. All right, so I'm going to do train underscore errors, comma, val underscore errors is equal to open close square brackets, comma, open close square brackets. What that's going to do is it's going to create an empty list that I can fill as I go through a for loop that we're going to build now. So for I in range 1 comma length of x underscore length x underscore train. So model dot fit x underscore train. So I want all of my data. That's what the colon says, up to point I. So So everything up to point I. I'm going to integrate 0, 1, 2. So it'll give me everything up to 0, everything up to 1, everything up to 2, everything up to 3. Sorry, I won't integrate 0 because I start at 1. So it'll give me everything up to 1, which is just 0.0, everything up to 2, which is 0.0 and 1. So that's what that colon I is. Comma, oh wait, I need a comma y underscore train square colon comma I, and that should run all of that. Now I need to predict next one out of bounds. Okay, yep, not a comma, sorry. All right, so it's running, so it's not throwing me any errors, so I'm just going to keep moving on. Y underscore train underscore predict is equal to model dot predict x underscore train comma colon I, and then y underscore val underscore predict equal to model dot predict x underscore val, and now I'm just going to feed it all of my validation data training sets, and I'm going to go ahead and feed it all of my validation set, not one at a time, because I'm trying to look at the effect of training my model, not the effect of validating my model. I might have misspoke that before when we were talking over the plots. Okay, so compute the error. So we're going to say compute the error for the trained model. So it's going to be MSC underscore train, mean squared error underscore train is equal to sk dot metrics dot mean underscore squared underscore error y underscore train square brackets colon of I comma y underscore train underscore predict. That's going to give me the difference of those. And now I'm going to go train underscore errors, which is that empty list I created before, dot append. And that's just going to say, hey, what do I want to stick on at the end of that list? I want to stick on MSC underscore train. APPEND, and that should give me train underscore errors. So I got 79. Good. Let's take a look at it. Plot. Boom. So I've got some sort of training error that goes up, down, plateaus. So far, so good. Don't know what the values are. I need to look at it in comparison to my validation to see if it's useful at all. But so I want to do this exact same thing. I'm just going to copy and paste it for the trained model, but now it's for the validated model, or the validation data, I guess. So that's going to be MSE underscore val. That's for validation. SK metrics. It's going to be y val, and not. It's going to be all of my y val, just my y val, and my y val predict. And then I'm going to update MSC val. I'm going to append that to val errors. Okay, so now I have the two of them. Let's plot them together to see what they look like, right? I'm just going to steal this plot from before, and that way you know what? Let's let's see what this looks like. Okay, so I'm going to go under that. I'm going to go plt.scatter. And I'm going to go x_train for everything up to I, comma, y_train for everything up to I. And now I'm going to go plt.scatter. plt.scatter x_val, comma, lowercase y_val. This is going to plot my validation data points, comma. I'm going to put marker equal to s, make that a square marker. And now if I want to run this in there. So let's go ahead and say, let's work through this. So I'm going to come up here at x length because I don't want this to run over and over and over and over and plot a ton of data points, right? Or a ton of plots. So I'm going to go x from 1 to 2, or better yet, I got a better idea. We're going to get rid of range. We're going to comment that out. We're just going to go in a list of 15. And now I should be able to just get one data point. Okay, marker. There we go. Now I've got data points, which are in blue, and then I have some validation data, and I have some training data. So it's a little hard to tell. Let's go ahead and make a label for this. So label is equal to data, and then comma label is equal to training data, and comma label is equal to validation data. Now none of that's useless if I don't have plt.legend. Oh, there you go. Puts it in a nice spot. So I've got blue is all of my data, and I haven't included it all yet, right? So this is just for an individual point. Orange is the data that I'm using to train the model with. So that's the only data that the model is going to see for training. And then green is the data that I'm using to validate the model with. And that validation data, that was done before the for loop, right? And so it's going to be the same every time.
So all the blue is unused?
So all the blue is currently unused, correct. So now I've built a model. So I built the model here. Model fit, right? So let's go ahead and I guess we have to extract that model. I'm going to do it up here. So I'm going to go y_model is equal to model.predict. I have to expand out my X model, but that's not really an issue. np.expand expand _ dimensions. That's just going to give me an extra dimension to deal with the NumPy array issue that it can have an on. It doesn't have a dimension intrinsically. X_model dot axis equals 1. And X model is not defined. So I need to define X model You can do that. No point to do it in the for loop. Probably do it here. So x underscore model. Whoop. Define x model. So capital X underscore model. What did we use before? np dot linspace from -3 to 3. All right, so now I have a model, and now I can go ahead and plot that model in my plot. So plt dot plot x underscore model, comma y underscore model, comma r dash dash, comma label is equal to model. All right, there's a model.
Is your code for the plot inside the for loop or no?
My code for the plot is inside the for loop, correct? So this is for a first order model. And for right now, I think we'll leave that. All right, I want to do something kind of cool, which is I want to save all of these. So I'm going to go plt.savefig. I'm going to say, let's put these all in a folder called test underscore plots, and then use a / linear underscore model underscore plus str of I. That should make a string of I. Now, if I hit F5, no file or directory test plots. That makes sense. So I need to go to where my code is saved. And I need to create a new folder, test plots. And now survey says it was happy to put this model in there. And now we can unleash the dragon that we have created. And let's make a lot of figures in a for loop. Wait, one more thing. You don't want them to all pop up because they can crash your computer, right? Because you will have thousands of data points that your computer is trying to render. So we're going to go plt.close all. Now we're going to hit F5. We're going to watch this little thing freak out here. Just kind of create plots. And if I go to my folder, beautiful. It is creating plots for me. All right, we have 80 data points because we split 100 data points, 80%. So let's go ahead and look at model number 1. Wonderful. Absolutely no error. I think I can zoom in. Nope. Okay. So absolutely no error. How beautiful is that? Because the model goes right through our one data point, right? And then it's tested against all of these green data points, which are for validation. So not actually very good. And then we get 2 data points. Where's the other one? It must be, you know what? It's got to be under one of these blue data points, but then another data point plotted on top of it, so I can't see it. So let's make a change to the code. Let's go scatter, comma, maybe you can do marker size equals 1. Is that a thing? Maybe it's just size equals 1. It might be S equals 1. There we go. All right, so that's a little bit too small, but let's go size equals 3. All right, that's not too bad, right? So we can see all the blue data that we're not using, but you kind of get a general idea of what it's supposed to be. And now we have 2 data sets. Oh, I can see just a bit of the orange. It's actually hiding behind the green here. So my model is fitting perfectly. I have absolutely no error in my model, and this would be a line at the bottom, or an overfit model. And then as I add more data sets, right, I can slowly get a model. Okay, this one's not actually too bad. My model's kind of following the general trend line of what I'm looking at. Oh, and now you'll see, right? So 1 data point, 2, 3, 4, adding lots of data. Model changes. Model's starting to look better. Model barely changes. Model barely changes. The model has become a lot more stable. As I add data points, you can see each orange dot popping up. And then you can see the model moving less to adjust to that. How cool is that? And so here we are at 32 data points. And as we continuously move and add data, the model keeps adjusting. But objectively, it's not going to be changing much. All right, so let's do one last thing. So outside of the for loop, let's go plt.figure. And let's go plt.grid true. Go plt.plot train underscore errors. And let's do that in a label is equal to train. And then I can just repeat that for val errors and validation. And then let's get XY labels and a legend. So X is number of training data points, and Y is error. And if you hit F5, it'll rerun the entire code, which I don't really want to do. So I'm just going to highlight it and hit F9. And I should get, oh, wonderful. Oh, look, it's about the same as the last one, too. So I get this nice plot of error versus number of training points, and it converges at about 10. We can go back and look at our plots to see if that's what actually happened. And then after 10, it kind of plateaus and does pretty well, right? It actually had very low error at about 3, but it's just kind of an oddity more than anything. And then we'll still notice that we have an error, a plateau around 3, which is relatively close to what we had, right? And before, because it's not a very good model, I want to make sure that's clear. Just because it converges, it means you're not overfitting, right? Or it means that you're training the model as well as you can. It does not mean that you have a good model, because again, this is our model. I can't get any better on this model. I'm not overtraining on my data set, on my training set, but I'm definitely underfitting to the data in totality. And so it told us that it kind of converged around 10. Here at model 4, 5, 6, 7, 8, 9, 10. And then from there, it kind of stays the same, which yeah, I mean, it looks about right. Right, so here it's kind of real sporadic, and then from 9 to 10, and then it kind of stays there. So those are learning plots, and that's how we can kind of quantify our models.